So good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon at 3 p.m. Eastern, trying to figure out what the future looks like for smarter buildings and related subjects. In case you're wondering who we are listed on mondaylive.org. Important to note that views expressed here on this show are personal, not of any company or organization. And please do post questions, comments, and other things on the Zoom chat. We want to make this as interactive as possible. And this slide deck is also available on the homepage of mondaylive.org in case you want any of the links on it. So this being March, we are talking about AI and specifically how AI and ML obviously fit into building systems and the impact and the relevance of that. That's a broad subject that we're covering in March. And so our agenda today, our normal chit chat, and then we're going to start to think about how AI and ML fit on the smarter stack, which obviously is the tool that we use to look at everything. So that's what we're going to do today, and also potentially the rest of March. But before we do that, I'm going to hand it over to Ken to tell us what's going on in your world, Ken.
Thanks, Anto. We wrote this article for Connected Contractor, inclusion of AI's value in our creative community collisions. Last month, we wrote an article about how we're seeing creative communities colliding with each other and interacting, and your jam and my jelly, and we're starting to see that, and it tends to be how we're starting to rebuild. And the newest piece is that the value of AI is becoming very significant and is rapidly growing. So we basically brought that out, and then I started a post on LinkedIn, which has got over 2,200 impressions so far in the last few days. The article went on last Wednesday, so I think I can't remember if I posted it Wednesday or Friday, or Wednesday or Thursday, and anyway, getting a reasonable amount of folks taking a look at that. We're starting to get some comments have called for everyone to put their input. So we're kind of running in between automated buildings and LinkedIn. The way we kind of look at that is automated buildings is kind of the library to house some of the descriptions of what it is we're doing as an industry. The noise and chatter is taken out into the hallways, which is social media like LinkedIn, and that's the place to discuss this. And then to link to these particular discussions. And it's amazing what folks write. I struggle to get them to write something on automated buildings, but they often will write pages on their comments on these posts. So yeah, a lot of stuff going on. I've also linked some interesting resources that I found to that same discussion. So it's actually kind of a dynamic build of some stuff that's going on in AI in our world. A couple of things I pulled out of it was a post that said, in the last 20 years, software swallowed the world. In the next 20 years, AI will swallow software. What do you think? So that's kind of an interesting concept. The other one that came up was the 2022 hype cycle for artificial intelligence, and we can kind of, if you zip in on that link, you can kind of see what in fact is happening there. We're definitely getting some stuff over the hype curve on the other side, and it's starting to become a reality. So I don't think you can ignore it. AI is here to stay and is going to change all of our lives. So I think it's great that we just need to talk about it. And I'm really pleased to publish anyone on this Monday Live has to offer. Back to you, Anto.
Okay, great. Thank you, Ken. I had a couple of pieces. The one on the left is on digital twins. I think all of these subjects, AI, digital twins, and other things are somewhat related. So this is not directly AI. But this is looking at what they've done. You know, this is from IoT Analytics, and I've used material from them before on Monday Live. Always very interesting visually, as well as how they think about things differently. So this is kind of the life of the asset is across the top here. And the stack up and down is really what they call it's basically the stack, the different types of products and entities, all the way from products all the way up to system prediction. And it's just interesting that they've identified these 6 application areas, and they're all at the sort of system level of the hierarchical architecture. So a lot of what we do in terms of smarter stack and the system or systems thinking is obviously in line with this. So I thought this was interesting just to bring up. And just the numbers are actually staggering. Obviously, 71% growth in 2 years for digital twin, and similar in other areas. And the second thing on the right is Arup. Arup's a very well-known global design and construction company, and they're obviously starting to look at AI and specifically in the design process, and some interesting sort of perspectives there in terms of, you know, how much AI can actually do versus what humans need to do in terms of things like designing a building is something obviously not highly suitable for AI because they don't have creativity, but there's a lot of sort of what they call force multiplier to actually augment what humans can do. And I think that's kind of the secret sauce of how AI is going to play out to a large degree. So those are the 2 that I came up with.
So Anso, when it refers, going back to the digital twin, when it refers to 63% of manufacturers, who are they referring to as a manufacturer?
I think this is broad in terms of IoT type products. I don't know without digging into it.
Okay, so it could be, do you think it's more likely to be a controls company versus a equipment manufacturer?
Yes, most likely it's IoT. So IoT controls is much more like IoT than the manufacturers.
Sure. Okay. So the fact that this came out of IoT Analytics says, yeah, okay, that makes sense. Yeah, interesting. The applications they're pointing to aren't the ones that I'm seeing necessarily seeing right now. We can talk about that another time.
Yeah. And Anno.
Actually, can you refresh? Because there's something on the right and it's not there. Maybe you caught me early.
There you go.
There you go. And that the IoT article that you posted on your page, I was going to do almost exactly the same thing because I read exactly the same article yesterday, and I was going to post that this afternoon, and you'd already beat me to the punch. So I went with a different thing. 2 interesting articles. They kind of complement each other from my perspective. One was just the other few weeks ago, Cushman & Wakefield kind of came out with this analysis of some 1.4 billion square feet of space will be obsolete by 2030.
It's in the US.
US, yes, US offices. Wow. Yeah, just US alone that's not a trivial number. I got the link down there in the Biz Now where this comes from. So it's actually a really interesting article on how they've come about their assessment on it. I'll give them their dues. I think they did a decent bottoms-up assessment on the approach. And then the one that I thought was complementary to that, if you haven't seen it, there's a lot of movement going on at the moment about, can we transition some of this unused space now into residence mixed, more of a mixed use buildings where they weren't mixed use in before. So this is actually an article where California's looking to try and change that. There's a lot of challenges with that, of course, that comes with, it's not that easy to, just infrastructure and services is from a residence is different to a commercial office. And then there's also, legislation, which is what the states are trying to overcome, to remove the actual legal barriers from changing it, and then deal with the, functional changes that are required. So interesting take. And then when you think about it, how does that change the technologies that we put into these facilities, that were just commercial and had commercial control systems now into residential systems, and how does all that mash up at the end of the day?
So Anna, did Cushman, in the Cushman article, did they also imply that there will be conversions to residential, or what?
In their article, they didn't. The residential thing is a separate theme, but I kind of I tied the two together, right? As people look to what else can we do with 1.4 billion square foot of
Yeah. So,
property.
but did they have any ideas in that regard? I mean, is people going to tear the buildings down, or what
theirs was really more of an analytic. It's like I said, have a read if you get a chance, because
yeah, well, yeah,
their numbers. I think they did a good, but they didn't really do those. So what?
Yeah. That's a huge number, needless to say.
Yeah.
And if you did a simple math of, I think I do this, I'm doing this right, converting them into apartments, that's 1 million apartments. Is that right? Did I do that right?
1.4 billion.
1,400 is kind of an apartment
average,
right?
but yeah,
that's 1 million apartments. Oh.
And there's, one of the things that the cities are interested in the conversion, of course, is driving the population back to downtown, from the previous few decades where we moved out, right? Can we, without having to build the buildings in the first place.
Right. Okay.
Okay.
Moving on, Rick, a few update bits from you.
Yeah, we'll do a quick update on C4SB, but I wanted to go back. Maybe we'll do a trivia question. This relates to some of the things we're going to be doing podcasts about. It's just the basics of our industry. That 1.4 billion square feet of office space, what percentage of US office space is that?
Are you asking for answers on chat?
Yeah, absolutely.
Okay, answers on chat. The winner gets a prize of?
I don't know. Well, yeah, you'll be the first one to be interviewed in our next podcast. So as a regular feature, I think every week or every couple of weeks, either Monica and I or somebody from C4SB will do a little update here. And for this one, our first update is that we are going to be forming a C4SB steering committee. And if you're interested in that, shoot either Monica or myself an email, and then over the next week we will be communicating what the nomination or application process is, and the intent is to have people from a broad set of the community or portions of the community, and then the steering committee will give guidance to what to focus on. We already have some ideas, and we already have some things that are going, but the steering committee will be influential in setting the path for what C4SB works on. Another group that has gotten started, or at least has gotten started a little bit, is what we're calling the under 40 group. I guess we have to be careful about age discrimination here, but the key thing is you don't have to have 30 years of industry experience to be able to participate. That disqualifies. In fact, we should make it a requirement that you don't have 30 years of experience, which would then disqualify most of this group. And as I say there, we're looking to have C4SB represent the broader community of folks that are interested, but maybe not yet totally involved or invested. And I'm not sure what this comment says, what Joseph Klotz is saying, but to be able to get people that are a little bit less experienced. And as part of that, there will be no intimidation, no judgment, no lectures, and absolutely no math. And again, please let Monica or I know if you're interested in that. Monica's heading that up. And then the other thing that we're starting to do is Monica's going to be doing video podcast interviews, very short, with the intent to answer some of the questions about the basics of our industry. And those will then be compiled into little vignettes on different subjects. And again, the intent is to answer some of the basics. And that was why it was perfect. You said 1.4 billion square feet. And well, what's the context of that? What percentage is the square feet? Anybody get it yet, by the way?
I did. It was 97 billion. So the percentage is 1.4 divided by 97.
97 is the total amount of commercial square feet.
Yeah. So it's almost 1.5%.
So that's the total commercial that includes malls and retail and everything.
Well, that's office. I did specifically office. Just office. Commercial office.
We'll look it up.
Yep.
We'll ask Chat GPT.
Yep.
Yeah, we'll get the fact checkers. Okay.
Right. But that's an example, is like we talk about things that go over the heads or not interesting the way that they're discussed, and we want to just make sure we're getting everybody's questions answered, in a broader way to bring more of the community in. So that's the C4SB update for this week.
Okay, thank you, Rick. And the community board, as I mentioned last week, we're just going to keep this up here and add any links as we need to. And again, this deck is available on mondaylive.org. Any other thoughts before we jump into AI? Okay, let's jump into AI. And we kind of wanted to think about AI in the context of the smarter stack. So I just put this slide just as a starter to get us going. And I sort of asked the question, what do we do today that behaves most like AI? That's kind of what I was thinking this morning. And I was thinking of specifically repetitive and continuous tasks that require automation. I mean, we are in the automation industry after all. And it occurs to me that these kinds of things that we do that sort of up and down the stack are some of the things that are likely to be touched by AI. The maintenance of the actual building itself, which is part of operations, alarms, who doesn't have problems with getting too many alarms? I mean, surely that's something that can benefit from AI. Prediction, obviously, that's an easy one. Matching, making sure data goes to the right places. So AI and ML is always very hungry for data. And then data sufficiency, making sure that the data has all of the attributes necessary. And PID loops, which is something that we actually discussed on Wednesday quite a lot. It's a form of artificial. It's not really intelligence as such. That's been around for literally hundreds of years, for at least 100 years anyway. So open it up to the floor. I don't know where we all want to start, but that's kind of the framing of this conversation. Who wants to start?
I could start with the PID thing and tell you that my brother and I actually owned a patent back in the CSI days. You remember this, Anto? Mm-hmm. We had a patent on a neural net or fuzzy logic based VAV controller that replaced the PID loops. That was 20 odd years ago. So, which by the way is an interesting side. Like, one of the reasons it didn't get a lot of interest was back then, terminology like AI and neural nets wasn't as well understood and defined today. And we used to use terms like fuzzy logic, which really threw a lot of people off because it was like, oh, it can't be as good because it's quote unquote fuzzy. And it sort of predates all the words there. I'm sure that bringing it back and using the more common parlance today would probably have a different impact. But one of the things that we did to do it was to solve the you know, one of the big challenges with, if you're familiar with controls within a VAV box, you know, a VAV box has what they call a double cascaded PID loop, right? Two PIDs, one PID controlled the flow, one PID controlled the temperature, and they were cascaded together. And the challenge always with VAV boxes, especially when you've got 400, 500, 600 boxes, is you technically have to set those PID or the PID parameters for each box and each loop, for each zone that you're doing it in. In those days, and today's technologies, they will use what they call adaptive PID loops, where it'll kind of learn what it needs to be set to. But the common issue that most VAV boxes are, you know, a relatively experienced controls guy would do for these spaces, the PID values should be these, and I've got 400 of those, copy paste close enough, right? And then the commissioning agent would just, he'd hood 1 or 2 boxes to, make sure that you're pretty close. And then, and get acceptance. And so we looked at using fuzzy logical, neural type learning to replace the actual PID modules so that you didn't have to set them in the first place. The logic would actually.
So Anna, you're referring to the tuning constants of the PID, proportional integral derivative constants, which did you do actual, when you did your patent work, or when you looked at this, did you look at essentially self-tuning PID that automatically calculates what those constants should be? Yeah,
so fuzzy logic. So self-tuning was an algorithm that would run on PID systems in those days and even today. The fuzzy kind of took it to the next step because it wasn't even you set it with target things, and much like machine learning does today, it was local self-learning type approach. So instead of auto tuning, the better definition would be machine learning based tuning. It would be a better approach.
I'd like to jump in on this too, because the whole PID thing needs to get lost. I mean, we haven't used that for years. As soon as we moved to DDC controls, we started writing our own algorithms, and none of them were proportional. They were mostly all time based, and we could always write a better algorithm than PID because PID was invented because the old devices could only react to a proportional change. And what we found is nothing is proportional, and the curves were not anything like proportional. So basically simulating the curves and moving to dynamic control. And of course, in the early days, I worked with Hartman and stuff. And so I came from a computer simulation world. And so all of our algorithms, we abandoned PID in the 80s. We no longer used it and pretty much wrote all of our own control algorithms. And I think that is pretty common. When you take things apart, they don't look like PID, the classical definition that ISA gives PID. So I think we should lose that whole term.
Well, I think that at the end of the day, Ken, and in the same comment to what Steve was talking about with auto tuning, and why PIDs were there in the first place, because PIDs is a very analog control. Anyone who's done analog controls, that's where it all came from, right? But back to the theme, this is a perfect example of why machine learning can replace the technologies at that lowest level, right? This is a great example of using machine learning because again, the technologies are as they are today, they're dated. People tend to do their own. Doing 500, 1,000 VAV boxes is a tedious task that gets messed up if you don't do it right. Yet that's the end point that the actual tenant feels, right? And then you get people like Comfy, right, who come along after the fact and go, well, I'm not going to deal with the root problem of why the control is not doing what it's going to do. I'm going to override that, and have the tenant be able to override that, through the BAS, through a sort of a bit of a backdoor roundabout process, as opposed to dealing with the root problem in the first place, right? What is wrong with the actual control loop from the VAV box? And why does it need expert engineering people to set it up and configure it to make it work correctly, when again, machine learning would be a great use case of replacing all that logic.
Yeah.
So
You
can
know-
I just make a comment to the audience? If you want to come and join us on screen here, if you have a view on any of this, one way or the other, just put up your hand and I'll bring you on. Sorry, Steve.
Yeah, I was just gonna, traditionally the PID was meant to control with greater accuracy. The original pneumatic controls basically were effectively proportional only. So coming in with a digital alternative with a full PID like they were doing in the industrial world did compensate for the time and elements. That's what the integral and the derivative part addresses. But at the end of the day, it was how accurate can I control to a set point, right? Well, where that gets a whole lot more complicated, and I remember one of the first jobs I ran into when I was living in Europe was trying to control chillers that were regulating the ice temperature in a hockey rink. And you had all these other variables that were influencing what temperature you wanted to produce your chill water at. You had the humidity inside and outside. You had the outside air. You had the ice temperature, and so how do you do that with a PID loop? Well, not easily, if at all. And that's what our answer at that time, which was in the early '90s, was to take advantage of neural nets and then fuzzy logic, because they could handle this multiple variant control problem, and then over time they learn and they adapt to tell you what the right set point should be under the conditions that you were facing in the moment.
Yeah, that's what we found too, is that we could solve control problems that would never been solved before, because if you put the PID loop in it, it doesn't work because it's not a proportional relationship. There's hysteresis and something. I don't know if you ever had a Joy in pitch motion fan and you tried to move this thing, it goes jerk, 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 and you try and control that with a proportional control. And I challenge you. I can write my own algorithm in 6 seconds to make it work. And a lot of stuff was like that. By watching the trends, you could actually write a better algorithm that had nothing to do with any kind of control, conventional control. And I guess coming from simulation, I was able to see a lot of that stuff. So, and then I ran into Tom Hartman, of course, and then we started, do we in fact want to maintain a constant temperature? And I'm still a great believer of that we don't really want to maintain constant temperature. We want to anticipate where it wants to be. We want to keep the people happy. If they're cold, we want to blow warm air on them. If they're hot, we want to blow cold air on them. That doesn't necessarily convert to a constant temperature. So anyway, there's a lot of dynamics going on in our industry. And I think we've been actually dealing with them, and some folks have come up with some pretty innovative solutions that probably are come fairly close to artificial intelligence.
So David, you asked to be brought on. Your thoughts? Go ahead.
Well, I'm going to support what Steve and Ken said. I was working with Distech Controls 25 years ago. And the point there is just set the temperature for the whole coldest or hottest day, make people at least, not complain. And when I was at the university with the utility, they were applying fuzzy logic and neural networks, but that's operating a nuclear power plant. I've seen it in variable speed drives. But in terms of people's temperature and their feeling in a building, we have now weather instantly. We have occupancy that affects the temperature in the room. Oh, yeah. So I think the PID loop is past its prime.
Yeah.
I guess just on that, as I said in last week, I've seen 3 proposals from AI companies adding to an existing building's BAS that was programmed. If this, do that, then make sure people have hot water and heat and don't complain and pay through the nose. And now we have time of use rates. So there's new applications for AI. It's just how do we bring them into buildings? Thanks.
I just want to reiterate before we go further with this, for our audience, is that What we're describing here is machine learning, or machine learning algorithms, which qualifies for this discussion.
Right.
I know as a result of ChatGPT, we got this notion of, writing a tome in 3 seconds, and that's AI, and this other stuff that we've been doing for 30 years doesn't count. It counts. Okay. Right. So just want to, take credit for what we've already accomplished with fundamental software technology in machine learning over the past 30 years, because it is significant. So just the point, so we don't dismiss it as, well, that doesn't matter. It does matter, and it's already in effect. It can get better, like anything else.
This is also part of the sort of the difference between AI and ML, right? Which we all get quite confused about, because in popular news, it's all about AI. ChatGPT is actually presented as an AI. I'm not even sure that ChatGPT is an AI. It's more of a learning thing, because it learns stuff.
Yeah.
Is that accurate?
And they admit their mistakes, even on 60 Minutes TV. So that's why we have to be bringing what AI is in the, the authoring world to operating a building.
I think to your question though, Anto, ChatGPT actually falls in the AI camp. So it is the easiest way to describe ChatGPT is what you and I can do on Google, right? I can go to Google and search a whole bunch of documents and assemble the documents and make it into a, cohesive message or story or whatever it is that you're looking for. That's all it really does. It actually doesn't learn anything in the process, right? It doesn't create anything new from the data that it assimilates. It's just assimilating the data that you've asked for, just like you can do manually if you went to Google, which, by the way, is why Google is, so scared of ChatGPT. It's basically putting the function of manual searching, into the powerhouse. It doesn't actually create anything new from the stuff it learns. It just assembles the stuff that you've got. So therefore, it falls more into the artificial intelligence of doing things that people do, but by machines, as opposed to machine learning, which would be like looking at data from VAV boxes and replacing the control loop.
But it isn't ChatGPT. I mean, it ingested a lot of information. Isn't that the learning that it's basically what ChatGPT is, or is
it didn't learn it? It just assembled it, right? And so it's a transformer, process-based transformer. So again, the thing is the easiest way. In fact, there was a great thing from what's his name, the physicist. What his name now? Tyson. No. Yeah. Anyway, so his point is like, if you asked ChatGPT to create a picture to paint a picture in the style of Monet, it can do that because it has all the history and all the styles and all the pictures of everything that Monet's ever created. If you said to ChatGPT, can you create a picture in a totally new style that no one has ever seen before? It can't do that. It has no data.
Didn't you just describe it learning Monet?
It didn't learn Monet. It just assembled all the stuff. So again, like the example is like, the kids writing essays, using ChatGPT. They've been doing that for years. You can go to Google, go write an essay on the, American Civil War. Okay, there is volumes and volumes of data available. It pulls it all together, and then it actually makes it into something that's coherent and flows. You can do the same stuff manually. It just does that now for you in a much more succinct way.
Okay. So I'm going to put up my slide back up just for a second, just to remind us, and maybe we can get some additional juices going on where else does it fit? I mean, something like alarms, I mean, that's part of delivery. I mean, is that an area of interest for AI to make sense of? Because what we don't really want alarms, we want actionable information to arrive at humans, right?
So that's a good example of probably falls more into the machine learning space than it does into the AI space, right? So In the case of alarms, I would rather use machine learning to, you know, filter out all the rubbish and stuff and what is really relevant and what's not relevant. So I need volumes and volumes of alarms to do that. Now, you could have a case, there is a case for AI for alarms, which talks more about, instead of someone looking through the list of alarms and, you know, assigning priorities or doing stuff with that, you know, do you want a robot to look through the list and to assign actions, assuming that your list of alarms are valid in the first place? So the two use cases would be an AI use case where a machine is looking through the alarms and assigning actions based on the fact that the alarms are actually valid in the first place. They're good data. And the other use case is a more machine learning use case, which is like, okay, look at the tens of millions of alarms I'm getting. You know, can you help me categorize those into what's actually a real alarm versus what's noise? So two different use cases. One clearly AI and the other one more for machine learning approach.
So Anno, you know, a lot of alarming is done on the basis of thresholds. Across the threshold, that's alarm, and you can have a green, yellow, red, kind of orange. You know, you can have different threshold levels. But it seems to me where AI could be really interesting, or machine learning, is anticipating the by studying the data before it ever reaches that threshold. Is it likely to reach the threshold based on how the data is trending at that point? So that's anticipatory, and for critical things that could be very valuable.
Yeah, absolutely. And I would put, so it's more predictive, but again, I would put that as an example of machine learning technologies as opposed to the AI. The AI would be, now that I've seen it, what would I do about it, right? Would I notify a work order? Would I notify a guy, you know,
right?
So what you just described is a great example of machine learning alarms. Yeah, can I predict something before it becomes an alarm? And that I need volumes of data to do, right? And that's why machine learning. Versus, for example, if you were to take the example of applying ChatGPT to alarms, right? I could see a use case. If I've got a building has generated millions of alarms or whatever, I could see in the use case of ChatGPT going like, you know, hey building, you know, show me the 10 most relevant alarms from last week, right? That's more of an AI exercise where the machine would then go through all the list of the alarms, prioritize them, define for last week, and come up with the list. It's not really analyzing the alarms, it's just doing something that I would have done as a person much faster, better, quicker. And that's why that's called more artificial intelligence approach.
I'll just jump in to say that CABA made a presentation on AI for predictive maintenance. So let's see if the motor is about to break, not an alarm after it breaks.
Right.
Maybe Jim could explain how we bring fault detection into the next level.
Yeah, I was just listening to the conversation intently, and I'm more of a top-down guy. You guys have started bottom up today, but to me, what we're trying to do here is put a virtual mechanical engineer in the basement of every building. And we've been working on analytics, and in fact, we've used a lot of these techniques over the years. Places where I see the most impact for AI ML approaches now are certainly the things you're talking about, but the fact is we've already been using these kinds of techniques to synthesize multiple alarms and other points for many years. The problems where this stuff really gets useful is in taking that stock of 5.5 million buildings that are, in cryptic old proprietary shape, and figuring out how to use AI and machine learning techniques to discover what's in those buildings to create the models that we use in effectively digital twins. So it's really powerful, and I'm very enthusiastic about what it can do there. The other area is in this idea of putting the virtual mechanical engineer in the basement of every building. So we have fewer and fewer people in the workforce, and we're looking at this. I think it's all of these applications, which are once again sort of small incremental applications, which will be flanged in by all the analytics vendors as the technology becomes available and good enough. So right now there are a lot of rules-based and statistical techniques. So I don't think that somebody's going to throw a switch tomorrow and all these things are going to rain down. I think incrementally over the next 5 to 10 years, as these, calls that exist that we can make to ChatGPT or any other AI that's going to be up there in the universe, I think those will just come into the analysis we already do. And the real trick is in how do we provide or impedance match the delivery of the data from the virtual mechanical engineer to someone in the building ecosystem to make that information actionable. Because one of the big problems we have now, even with the great analytics that we have, is you can lead a horse to water, but you can't make them drink. And, where we really need the AI is in the CFO's office so that they can, potentially we can bubble the information up to there, because that's where the decision-making is just plain stupid right now.
So Jim, just to drill down a little bit on the virtual mechanical engineer, do you think AI, discovering, like David was talking about, that there's a predictive maintenance event about to happen, right? So I see I'm in trouble. There's two issues there that I say. One is knowing what to do about it, right? So if I'm not really qualified as a mechanical engineer, how do I know what I'm supposed to do? What recommendations, what steps am I supposed to take, right? But then in order to do that, you need to do that in the context of the mechanical and electrical systems that are in the building, which are going to be widely different.
Absolutely. And this is where that metadata that you can collect on those systems comes in really handy.
Mm-hmm.
And ask yourself some basic questions. How come in maintenance management tools, nobody has ever completed the task of filling in all the spare parts, right?
Mm-hmm.
Most maintenance management systems are ticket systems because
Right.
nobody has ever had the time or the inclination to enter in every screw thread and belt size.
Mm-hmm.
So what we do today, Steve, is we actually do use humans sitting on top of the machine learning and the AI and the rules-based analysis. And I think that as AI gets better and better, it'll get better. But the human knows, oh, this is sort of a slovenly customer, and and they have generally this vintage of gear.
Mm-hmm.
And we can use that. We can use that human input to overlay. Eventually, the machine might be able to learn that, but that variability is really a key question. And how much of it can you capture from
Right.
looking at the site? How much can you capture the metadata that goes into the process? And when you can't, there's a really interesting thing to discover here. It doesn't have to be right 100% of the time to be useful, because the human isn't right 100% of the time.
Sure.
It just has to be flagged so that somebody says, you know what, I think that you need to change this belt, or this bearing is failing. And I'd say that there's a 90% chance that's true. Let's bubble all the 90% chances up and let's have the human look at them.
Mm-hmm.
That's what we do in our business.
And do you think it can, let's say there's a bearing issue, right? Do you think it can go the next step of seeing whether that bearing is available in a as a spare part potentially, or through, is it now obsolete? In other words, can it reach across multiple databases to say, hey, you got a problem here, but can you really deal with the problem if the parts is not available anywhere?
Yeah, and I mean, I think the question there is the question across the board here, which is the juice worth the squeeze?
Yeah.
So, and the juice historically has not been worth the squeeze on maintenance management for anybody to ever do it.
Mm-hmm.
They certainly use the maintenance management tools, but a traditional maintenance management system could not do what you just said.
Right.
And so if you had aggregation, or if you had companies that were in the business or could create business models around aggregating that data, or if manufacturers used it as a selling point. So let me give you an example. One of the things that's a great leap forward is BIM models, right? one of the things that's always been terrible about BIM models, unfortunately, is the industry foundation classes don't contain the kinds of information we really need.
Right.
But when anyone designs a building now and they select that rooftop unit or that chiller, theoretically, those components are ready for download from the manufacturer.
Hmm.
So going forward, we've got a 10 times easier chance if every manufacturer builds into their bid spec that all of those specifications are going to be included digitally. This
So,
is
that's the point of putting these two items here, the matching and sufficiency. It's all about bringing in the data. I wasn't sure what word to put here for the exchange, but I use matching.
But there,
In other words, you need to have data about the stuff that's in the building to make decisions on in the first place, and potentially to make remedial decisions as well.
correct.
To do something about that.
in some of the larger hospitals, the BAS is talking BACnet to the CMMS that knows the part is there, knows who's qualified. So that's another opportunity where using CMMS and the data in CMMS to cross knowledge between a chiller in hospital A versus hospital B and why it's not operating the same way. So there are advances in that as well.
And back, in fact, to your point, David, one of the things I get told endlessly is that back to the matching use of AI, and again, this is more of an AI example. The discrepancies between the metadata that's in the CMMS versus the BMS and any other databases that, maintenance management systems are horrifically out of date and not well maintained and not kept up to date. And we hear lots of,
that's where we need Mark to talk about Project Haystack, where you name everything the same so the data will talk to each other.
Yeah, but the challenge though, David, that's great if you've got starting at base 0, but most of these places already have large CMMSs and large databases already installed. So back to the matching problem, how do you match all that up, and how do you get all that cleaned out, and how do you make that usable without throwing it all in the trash can and trying to start it all again, which is probably not a good start. So
I think AI is your answer.
Exactly. That's what I was going, right, Jim? I think that's another great use case.
IBM is going to use its Maximo or its open source to do it, to improve all its software. It has facility software. It has Maximo running airports. So the applications are endless, as Ken said.
Jim, you were going to say something else to that?
I think I forgot what it was, Anto. So no, I mean, I just think that these intermediate translations from legacy to some of these open systems is very important. And if manufacturers of equipment were to go back retroactively and provide some of this data in these models, that would help a lot. Because once we know the topologies, the equipment, and the system, we can discover quite a bit of that and add them to the models. But I think Toby Considine asked a question online, and I think it's a really important one. And it's to my point where I tried to say, is the juice worth the squeeze? Right. Is there enough money in automating these things? Can we save enough money by doing this to make a difference? And the answer sometimes is yes, and other times is no. And of course, that answer will change over time as price points of technology change. But, when you have a disruptive technology, you need orders of magnitude improvement. 20 or 30% doesn't get a disruptive technology adopted. I'm a poster child for that.
So if given a disruptive technology or something that we don't know that can actually make data become very much easier to match and use in an AI environment, then it will actually make everything up and down the stack better with regards to AI and ML. Is that one way of thinking about it?
Absolutely. And so the stand theoretically, one of the things the AI should be very good at is learning the genre of things that can be standardized and moving those over the lines. One of the problems we have is it's just an enormous task to go back and haystack the world or BIM the world or whatever.
Right.
But AI, theoretically, if if it's well worked out, should be able to help with that problem.
Which,
Because I often get, when I talk about integration and bringing things together, I often get people saying, why do you need that piece of information? Why do you need to store that? And you get that question asked over and over again. And I have a sort of different view that says, gather the data or make it accessible, and then you'll figure out what to do with it of some value later on down the road. Is that the right approach?
Actually, that's I run into that one all the time as well, Anto, and I find people absolutely fall into one or either of those camps. There seems to be no middle ground. There's definitely the folks that I talk to who will go like, yeah, let's get the data and we'll work out what to do with it later, because they've heard buzzwords like, machine learning needs lots of data to do so I better start collecting data before so I can make it useful, even though I'm not sure what to do with it. And then there's the other side of the camp of, why should I bother if I don't know what the use case is going to be? If you can't tell me what the use case is going to be, 2 years from now, then why am I bothering in the first place? And they both have valid views on it, but
I have both views, Anno. I'm of the camp that you really shouldn't try to do analytics without a premeditated understanding of the endpoint that you're trying to get to, because you need the data sufficiency. But on the other hand, I think that with AI and ML, that having all this other data opens up new possibilities. So when you're establishing a value proposition, you need to know what it is, and you need to know the data sufficiency for that value proposition. That's not to say that collecting this data doesn't have great utility.
And it's complex, right? Back to your point. I'm sorry, Steve, I jumped all over you, man.
okay. Yeah, I just want to I think the word I would use is usable data, and it ties into the Div 2525 work that we've been doing for the past couple of months. It just underlies how important that is. So, because we talk about the different layers and what we need to do to represent data so that it's usable, so that as AI comes along and it's able to immediately take advantage of it, because right now it's going to be really hard for it to take advantage of the data because it's so poorly represented.
Yeah, that helps, but you may not actually understand that usefulness of it without some other context.
And when you report to GREBS and you have ESG reporting, you need scientifically based facts to report on what your building actually did and what energy intensity it was and what carbon content it may have.
Rick, I think you were about to say something.
I hate to use a crazy analogy, but just a decade or so ago, a whole bunch of people got a new view of the usefulness of data, and it was in a movie that starred Brad Pitt called Moneyball. So previous to a certain point in history, it didn't matter whether the base hit or was to left field or to shallow right, didn't matter. And then more data started getting collected, and fast enough computers and smart enough, analysts came along, and enough data and history came along, happened, that you could start to get a better forecast of what was going to happen based on a particular situation. And so then all of a sudden, it was like everybody's scouring through the old history books to see, where did that base hit go? What was that, a curveball or was that a fastball? So so my theory is we should be collecting as much data about operational things as possible, because as we get more powerful computers, more storage, better communications, there's a chance that, to Jim Lee's point, there's a chance we'll get to a point where there's enough data about similar things that we'll be able to do some forecasting about what is coming up.
Well, the ideal model, of course, is you collect all this other data on not the premise, but the misdirection of doing something else, right? And so the perfect example is Google, or even what the chat. So Google has been their business model of collecting the data is to provide you with search capabilities. Yeah, the real value of what they're doing is all the data that they're collecting, right? So if you want to put the right business model together, is solve the current problem with the data that you're collecting, knowing that you're going to use it for other purposes in the future.
but the machines they're using to figure out what ads to send to me and how to listen to what we talk about, whether it's barbecue
Robots
sauce
are
or
good.
whatever.
Robots are good.
We love the machines.
We love the
computers.
robots.
We love the robots. But the algorithms and the power that was created in the social graph and all the different mechanisms for being able to analyze big sets of discombobulated data has been fascinating. And now people can use that for other less advertising related things. And again, that's why people are excited about ChatGPT. That's why we're having these sessions, because people are all of a sudden now at a point where it's like, wow, this is really interesting.
Right.
So gather the data, understand the data, tagging and other mechanisms, so that it's not just absolute raw data, so that you can actually use it later. So
and push for people that have that data at their fingertips to help inject it into the system, like into the entire design build automation chain for buildings, right? Let's get the equipment specifications out there, not just the control parameters, right?
And there are millions of rooftops, as James Dice said, 80% of the buildings don't even have a BAS. So what are we going to add it to? What data is going to come from it? But it could be thousands of rooftops on different stores of the same brand.
A lot of those rooftops have controllers on them. It's just, once again, is the juice worth the squeeze to get the data out?
Well, but we weren't going to do anything with the data anyway. So you can't necessarily blame, and this is one of those chicken and egg things, right? If the manufacturers know that we're going to do something with it, then maybe they'll go ahead and put that extra COM chip in there to allow for the data to be able to, or maybe they'll actually start to organize the data in a way that we're suggesting.
The 23-year-old York rooftops that I have on the roof of my building have data communication outputs. If we want to get the data, we can get it. Just, is it worth it?
But I think the point is that when you ask the question, is it worth it? It's based on a very specific use case of today, and the data that's necessary for that may be totally flipped in 3 years down the road, when you have just so much data that the question is no longer valid, because there's the getting of the data wasn't hard. It's just there. You just use it, so you can squeeze that little extra drop from the orange.
Right.
There are companies putting it in rooftops. They're claiming it's AI. What is it really doing? We'll see. And Clarity, which is one of them, has been working on this.
Okay,
it's
any other
to put in devices to be able to collect the data. It used to be the only route out through a building was you had to put everything through the building automation system, which was not exactly ideal. It's like I used to tell Anna all the time, nobody wants to put their HR data into the thermostat. Nobody wants to put their occupancy data into the thermostat system.
Correlation is important.
Yeah, that's a key point. That's a key point. That's a key point, Rick, that the only sort of model that we've had up to now is really the BAS system, and we're going to break out of that. And Anna keeps on talking about IoT systems, and obviously everything is effectively an IT system now, so it gives us lots of different ways to think about that. So we should bring this to a wrap, coming to the end of our call. Hello, Tracy.
Hi, so happy I could join.
Yeah, useful.
Take us
The
home.
meeting didn't adjust the time. I forgot about the time difference, and Arizona flips because we don't change our time, so I screwed up today. Sorry, guys.
That's all right.
Okay, all right. So we'll bring this to a wrap. A bit of programming note. I'm not going to be here next week. I'm going to hand over the keys to Anna Scholten, who's going to be hosting and moderating. So
You're all lost.
Sorry about that to everybody, but I'll be somewhere else, and wishing you a happy, great week and great shows for the next couple of weeks. So with that, bid you farewell, and video will be up tomorrow or the day after. Bye-bye all.
See ya.
Cheers.